Hey, what's up, everybody? Find K pairs with small sums. I can't even find a girlfriend myself, and I'm finding pairs for LeetCode. Alright, let's get started. Hey, you're given two integer arrays, nums1 and nums2, stored in ascending order and an integer k. Define a pair UV which consists of one element from the first array and one element from the second array. Find the k pairs u1, v1, so these values with smallest sums. So let's take a look at an example. Excuse me. So first you have 171, 1711 for the first array, and then you have 246 for the second array, and then k is 3, and the output is 1, 2, and 1, 4, and a 1, 6. Because right now we can just get the results with our eyeballs. Like we can just eyeball the results. 1, 2, 1 from here, 2 from here, and we can immediately tell that 4 is less than 7. So we have 1, 4, and then 6 is obviously also 7, smaller than 7. So we'll add 1, 6. And the first pair, 3 pairs are returned from the sequence 1, 4, 1, 2, 1, 4, 1, 6, 7, 2, 7, 4. So, and numbers 1, 1, 1, 2, and 1, 2, 3. Case 2, so we want the first two pairs. The output is 1, 1, and 1, 1. So the first two pairs are returned from the sequence 1, 1, 1, 1, 1, 2, and 2, 1, because 1, 2, and then the 2, 1, and 1, 2, and 2, 1, 1, 3, 1, 3, 2, 3. So, and then we'll have 1, 2, nums 3. We'll have 1, 2, and 3. The k is 3, so well, at most we can only return two pairs, which is 1, 3, and 2, 3. So very straightforward. You are trying to get k pairs from two arrays. K pairs from a selection of two integers from two arrays respectively, and the arrays are sorted ascendingly. So right now on the top of my head, the solution I have is we'll start from the first element in each array, and then we will, so obviously because the arrays are sorted in ascending order, so we for sure we know that the very first elements of each array, the sum of the first elements of each array will be the smallest. So we guarantee to have the we're guaranteed to have the pair we want just simply by grabbing the first element of each array. Now the problem is what do we do after this, right? Now, because this is in ascending order, we can compare the next element. So we'll see if the next, let's say, if the next element of array 1 is larger than array 2, right? If the next element of array 1 is larger than the first element of array 2, well, if it's larger, if the next element of array 1 is larger than the next element of array 2, so we'll compare them, and if this one is larger than this one, then we'll move the index of array 2 forward to the smaller the next smaller element. And this is how we get the second smallest pair. Uh, there's one problem with this because it seems like every time we will, I mean, once, so this is good. This is all good because we will keep comparing this, and every time we move on to, we'll keep comparing this every time we move on to the next array. Now, but the problem is that once we reach, once say array 2, the next element of array 2 is larger than this, then we will have to compare all the elements on array 1 all over again. So if we just simply try to find the smallest pairs by simply comparing the numbers in between, then it's going to have a problem. Well, it's not a problem, it's just going to have a slow performance. It's going to be n times n because let's say the size of array 1 is m and the size of array 2 is n. So for every number, we pretty much have to keep looking through the other array to see if it's the smallest. So what can we do to optimize this? So for sure, so can we? So in order to reduce this expensive comparison, the well every time what we need to care about is just the smallest pair. Every time we try to take a pair out of these two arrays, we just care about the smallest. So whenever you think of something smallest or something k or the smallest k, the first reaction should be it should be like a natural reflection, right? It just like it should be something like when the doctor hit on your knees and then your knees will jump, and then whenever you see a hot girl passing by, it's like, whoo, wow, damn girl, like this, right? Um, Anyways, it should be a natural reflection that whenever you see something k or smallest, you first thing you can think of, but it's not always the true. But first thing that you should come up to my mind is priority queue, because priority queue always gives you the smallest number, pair, whatever element, and while relatively maintains a relatively fast performance. So if we say have one, if we have, so first of all, we'll be sure that first pair, the pair of the first element of each array will be what we want. So we'll add this to the queue, and then can we? But we don't know which element has a smaller. We don't know which array has the next bigger element. So maybe we should just add, let's say A1 from array 1, and then A2 from array 2. Maybe we can just add A1 to B1, A1, B1, C1, D1 paired up with A2. So we can add these to the priority queue first, and then we will compare one by one in array 2 and see. And while we're comparing, we'll keep adding the pair to, we'll keep adding the pair to the queue. So okay, let's see. And with this method, yes, we will have to go through m, but then for uh, every element in the arrays, we'll have to go through one. Only need to go through one. Now the problem is every time we compare it, we'll have to do. It's sort of like m plus n times m plus n. So it will be. God. So the performance will be m plus n times log. So it's n log n, right? Because that's the performance of priority queue. So n plus n plus n, which is still better than the original brute force solution, which is n times n. So yeah, I think we can go ahead with this implementation. Let's see how much time we have. Okay. All right. So first of all, we need to have a null check because we make sure they're all above 0. So we have length is equal to numbers 1 dot length and int length 2 equals to numbers 2 dot length. Okay. And then if length 1 is equal to 0 or length 2 is equal to 0, then there's no point of doing this. We will just return null. Actually, we'll give it another check, or k is equal to 0, then we're done. So now we will create a priority queue so that we can start adding. Well, first of all, we need to have a list of integer list to save the results. So first we'll have list and list integer, and we will have, okay, so we'll have save results and a new linked list. Okay, so and we should we apply all re to queue, and the priority queue would be something that you use to save the pair. So what other information that we need to so what information do we need to do the comparison? So first, since we already have the indexes, so I'm sorry. So obviously we need to compare the value of these two pairs. Obviously we need to compare the values of these two elements from a pair, and then we need to keep track of the. So since we have already we'll have added all the elements from one array to the queue, we'll need to keep track of the element from another array, the index of the element from another array, because first of all we need to make sure it has already reached the end of that array. Yes, that's the main part, and also that's how we keep incrementing it, right? So and in case the next element, well, I guess it's hard to explain. Well, let's see. Damn it, I need to work on explaining my thought process better. It's 15 minutes. So we'll have int array of integer to keep track of the values value of A1, value of A2, let's just call it A1 and A2 respectively, and the index of this A2 element. So priority queue, let's call it Q, and then we'll have new priority queue. And then we'll int. Now we need to implement the comparison function, so which is A, B, and then we'll have A dot. So A0 minus B0 plus A1 minus B1. So okay, so yes, so because priority queue is sorted in descending order, always gives you the minimum. So priority queue is essentially mean heap. So it will always give you the smallest. So this is how you compare the. Let me see if A minus B0 plus A. Okay, that's right. Yes. Okay, so now. And the first thing we need to do is to add all the elements from one of the arrays to the priority queue. So for integer I is equal to 0 and I less than and 1 and I plus plus. Okay, and then we'll add Q. I think it's Paul. Or so the Q, the is it Paul or what's the API called other than I haven't used a Q for a while. Is it offer? I think it's offer. Okay. Offer new int. How do you initialize it? Is it this? We'll see. So we'll have nums1 and I, as well as nums2 0, and then you add I. Well, we don't even need to add I. Well, this is 0, right? So this is the index of the we can see my hand. So this is the index of element 2, so that we can keep track of it later. Okay, so we'll offer this, and then okay, now it's the show begins. Well, while so what we do, the next iteration should be while k is larger, or while we have not reached the q is not empty, right? If q is empty, then then we should stop. So, well, Q size is not equal to 0, and or and K so is larger than 0. Also, you will need to decrease K. Well, I'll do that later. So Q size is not equal to 0 and K is larger than 0, we will return results. We'll return a list of the results, a pair to the result list. So first of all, we'll have list. Now, first of all we'll take the first element off of the Q first. And what is Q? Q is integer, so we'll have int plus a temp is equal to Q poll let me see, make sure that this is, god damn it, I have only 8 minutes left. Okay, poll, and then we will have list integer list new linked list, and then list add temp 0 and list add temp 1. Okay, we have this pair, and then we'll add it to the results. So result.add list. Okay, and after this, what do? We will add, so since we have already added this pair, we will need to increment the index of the element from the second array, right? So, but first of all, we need to make sure that the index of this current array, if incremented, is not going to overflow to the array. So if temp 2, which is the index of the array from the second element, from the second array, plus 1 is less than 2. Well, if it's less than, then we can do the incrementation, right? Incrementation, the increment. Okay, so we'll Q over new int nums1 I and nums2 then temp 2. Let me do this. Index 2 is equal to temp 2. So that we can reuse this variable. Temp 2 plus 1. And then we'll keep track of this index. Is temp index 2 plus 1. Okay. And then we will, don't forget one thing is that we have already added the result, so k will be minus minus here. At the end, we will return results. Okay. Oh, well, we have 5 minutes to debug. So let's see, 1710. So let's see if this example will work. Okay, let's just see two examples. So 1 1, let's see the simplest example. So let's say 1 1 1. Okay, so let's say 1 1 2 1 2 3. So first of all, you will add all the. So first of all, we'll add all the uh, elements from array 1 to the queue. So we have 1 2 1 1 1 2 and 1 1 1 1 and 2 1. And then, well, size is not equal to 0, and you will pull q first, so you have 1 1, which is the result, and then you will have, god damn it, I feel like I don't have time, 4 minutes, and then k minus minus, okay, so k becomes 2, and then k plus 1, index plus 1 is less than 2. Okay, so while index right now is 0, so we will offer a 0 plus 1, which is you'll add the current number, which is 1 1 2 to the queue. Okay, so the queue now still has 3 elements, and then the next one is 1 2. So I guess I guess I'll just run through the code of that. I'm afraid I don't have time to. 15. Yeah. How do you initialize this? Int. Oh wait. I feel like you have to add a square bracket in between, right? Cannot find symbol. Of a new int nums 1 is I. Wait, what the fuck is I? Oh, what am I thinking? It's temp 0. Wait. It should be temp 0. And then numbers 2, index 1, and then numbers 1 should be temp 0. One, 2, 1, 4, 1, 6. Looks about right. I'll submit it first. Okay. Wrong! Oh, god damn it. No. Output no. Expect. What the heck is. So you should return. So if k is not equal to 0, you should return no. Okay. What about now? Are you happy now? God damn it. Oh, wait. Okay. So, I mean, you don't even need to check anymore. So, if queue size is not equal to 0, if you don't do this check, it will just return empty list. So let's see. Wait, runtime error. God damn it. 3, 2, line 15. Array out of index. Oh. line 15. Array index out of bound. 3579. Oh. Wait, really? So we need to also check and length 2 is not equal to 0. It's ridiculous. Let's see. Submit it again. Accept it. Okay, cool, awesome. Wow. Went over time a little bit, but there's some stupid edge cases. All right. So yes, let's learn from this question is whenever you see, I'm not sure if this is the best solution though. I need to check. Well, never mind. I feel I'm done of time. I guess I'll just do a quick explanation. Since we're going too much time, it's been 30 minutes, right? Okay. Okay, so yeah, so let's learn from this is whenever you see the k smallest or find smallest whatever, you always think of priority queue first. And then you can go from there. All right. Thanks for watching, and I'll see you next time.